Welcome to Herbert Junior Surface Grinder Mark II Part 3, and welcome to Aeroplane, which is always flying by whenever I'm trying to video. At the end of this video I'm going to post up some pictures of a mystery machine. I've never seen anything like it. You might know what it is. This is not some kind of corny trick, we just don't know what it is. Anyway, that'll come later. So with the other parts on order and the paint, I think it's time to look at these bearings and see what needs to be done there. Just as a reminder, they're dry. I don't know if you can hear that. Well, I'm sure you can. Now, there's a locking collar here with a locking screw. I don't know if that's just for the pulley or whether the bearings are tapered. I don't think they're tapered. Let's get it off and have a look. Oh, machine's rolling away. Still on rollers. I'm going to assume this is right hand thread. I've taken the screw right out because it screws through both plates. Yes, it's right hand thread. Just a minute. Oh, look, that's raised there. Oh, how's it do that then? Let's see if we can shock this into freeing off. Yes. Some of the noise on this shaft is end float. It's not up and down. So before I go too far with trying to get that pulley off, I'll take these screws out, get this cover off, and just maybe I can have a look inside at the bearing. Oh, well, there is a bit of grease in there, look. Well, it seems like this bearing may be okay. I think it's the back bearing that's giving us the trouble, so that pulley has to come off. I've got the pulley off loose anyway by gently wedging it behind. Because it's cast, I could easily break it. Now don't lose the two keys. I've made a mark on it here, and I've also popped it just there. Let's see what we can see from here if we take these switches off. I think there's just a bearing tube inside. These are disconnected, and one of them is stuck. Yeah, there's a tube. I've got a feeling this tube and the bearings might come out as one if I tap from the back on the end of this tube, if I can get to it. Not tapping the shaft. I mean, this looks as if it's pressed into here. I'm sure it will be. I don't see any places where a screw would go. You know, like an Allen locking screw or anything. You see, I could just grease these and hope for the best. I'd rather diagnose any problems now before they're all greased up. I can see some numbers, I think, on this end bearing, the back end bearing. I might just try and read what they are. R&M, Ransom and Marles. Later, I think, Ransom, Hoffman and Pollard. LRJ20. There's a digit in front, which might be an 8. Somebody's engraved, I think, 20,000 on there. This is a brilliant camera, you know. It's just a Sony camcorder, but a top-end one. And people say, oh, I don't go for those, you know, messing about with a tripod. I use a GoPro. Well, can a GoPro do that, do you think? I've tried to find those bearings and I can't, but I do know they're high precision matched bearings. It could all be very expensive. But I found if I tap this, I can actually tap the shaft out. I thought it might have been the whole tube has to come out, but apparently not. So if I can do this, we can inspect the bearings, hopefully. It's only this end one, I'm sure, that's giving us bother, is what I mean. That's wiggling already. Ah, there's a sleeve or something behind this. Ah, there's like a tensioner. Or is it? I don't know. Hold on. Right, this whole tube is coming out. Ah, now then. Not ball bearings, as it said on lathes.co.uk. Rollers. No, I hope I don't lose any of these. I have to be careful. There's a double bearing at this end, and there's a sort of floating collar. The rear outer race has stayed in the machine, but it's still readable, even through the machine spindle. Well, I've done my best to clean this up. I think the problem is it was packed with grease when it was put together, but it's never been greased since. So the grease on this pulley end bearing was really quite dry and horrible. And then this spacer, it slides right over, and I could see, I can't do it right now, but I could see that it had no grease behind it. There was no grease in that ring there. Now there's a relief around here and 3 holes. And those 3 holes are supposed to let the grease in from the grease fitting, which comes in about there, and at the back it comes in about there. So I've done my best. There was grease in here and the grease was in reasonable condition, but I've done my best to clean it out with some brake cleaner, and I'll grease it all up with lithium grease and put it back together. Now these bearings, particularly this one, I can't really read that one, it says thrust on it, and it's 2 opposing, probably annular contact bearings as a guess, I don't know for sure. And then this is pretty clear what this is, but I don't think it's tapered, it's just roller. Anyway, I've been very careful not to lose one of those rollers, because if I do, you know what you know what sort of bad situation I'd be in. So I need to get this back together, and to make sure I don't catch the edge of one of these rollers and flip it out down into the machine. So I'll grease it up first before I start. I thought as much. Trying to put that shaft back in, you can't get those rollers within this outer race, even with the grease on. So I'm going to have to take that out, give it a tap out, put my hand inside, and then this will have to go onto the bearing, then the whole lot tapped in together. Well, 2 bits came out, the outer race there, and then this sort of collar which goes on the end. You know, with everything assembled here on the shaft, so the front collar and the back collar here, and the bearing and the bearings, I've just been checking where the greasing points emerge, and the front one emerges 20 millimeters from this face, which is fine. It lines up perfectly with this relief in this spacer here. Good. This side, it emerges 25 from this face of this collar here. Now where does the grease go? There is nothing, absolutely nothing, or nowhere for that grease to go. But looking at this end, look, there are these. Now what are these for? There's a relief here and a couple of channels, this one and the one at the other side, 180 opposed. And it would make more sense to me if this was the other way around, because this has its greasing point, this has none. If these were here, the grease would come in about this point, somewhere here, equivalent, and the grease would go into the bearing. So did somebody put this on the wrong way around? Nobody seems to have a manual for these. Now to turn this round, I'd have to get this bearing inner off this shaft, swap this round, put it back. I'm quite tempted to do it because I can't make any sense of it any other way. I've been thinking about this overnight, and I did a bit of research, and I can see I can get an LRJ20, seemingly original, £35. That's the cheapest I could find it. Somewhere else I saw it for £105. Now I know bearings have different tolerances and accuracies and so on. I need to do more research, but now I think I can get another. I'm going to definitely take it off and swap this sleeve round, because I'm sure that's on the wrong way around. Now you can get a manual. Lathes.co.uk do sell a full parts manual, but it's £27, and I don't really want to do that, spend that money just now. By the way, I'll just say that £1 is 1.2 US dollars at the moment, about that, just so you know. So I'm using this, what we call a Stanley knife, and bashing the blade into the gap, and I've smashed the blade, but even so I've started to get this to move. No, can't get it off now. Oh, never mind. It's moving. So bit by bit, I've lost a bit of the blade there. I don't want to cut myself. That's it. Next size screwdriver. Good way of wrecking your screwdrivers, this. It's coming anyway. Let's go big. Oh, stand still, will you? That's it. I'll come back when it's done. So be my witness, the writing on that bearing is on the outside. There's nothing on the inside. Just in case we do use it again, let's get this sleeve off. Now this sleeve, it doesn't take any of the load of this shaft. That's held between the two bearings. This is to keep the dirt out, I think, but it's also it's a spacer. And I think it should be that way. So we'll do a bit of investigation. Grease is a bit mucky. Yeah. Seems to go on either way, doesn't seem to care. Well, I've taken one roller out, and I'm looking to see if that surface is broken up. And it's not. You can see I'm just trying to save money. I don't want to spend all that money on something that makes no difference, right? I mean, who would? But having said that, there's quite a lot of rock on it, look. And when I spin it in front of the microphone, you'll hear it. It's just a little bit rough. Listen. I think it's probably shot, if I'm really honest with myself. We'll see if we can get one. Well, I've measured it up before I make the call to try and get another. 47mm outer, 20mm inner, 14mm deep. So I'm quite surprised that that's metric. Anyway, in other news, this has arrived. A 14 microfarad capacitor, which I'm going to use to drive the motor. But we'll talk about that later when I'm doing all the electrical work. Well, an hour later, and I've ordered the replacement bearing. I went for an SKF NU204 ECP. And it was £30, well, £29.50 delivered. And it will be an SKF, because quite often when you order these things, they don't have SKF. They send you a substitute, but they say, yes, it will be SKF, because I wanted a definite quality bearing. And now that I know that this outer is 47 and the inner is 20, I now understand these numbers that were engraved on here. If you saw the shot from the end on of this bearing, you'll know what I mean. So what they've done is, when they were manufacturing this machine, they measured this bearing to within 1,000th of a millimetre. So that's as 20,000, but what it's saying is 20 millimetres, 0.0000 actually. And then when I look at the outer, this is upside down for you and you can probably not see it, but 46.9950. That's pretty scary, isn't it? You know, the people who can actually manufacture to that level of accuracy. It sounds as if they have literally bored the machine to suit that exact bearing, but we shall see. Anyway, bearing's on its way. Now I'm going to spend the rest of the day just cleaning up these remaining parts that have got red on. So this and the shield that goes around the wheel and a few other bits. I'll do that today. I've got more stuff coming tomorrow. We'll see what arrives. I'm going to have another go with this degreaser. I think what I did before, 1 capful per litre, is probably alright for doing something like a kitchen floor, but it's no use for this. And when I read the instructions fully, it says, oh, 1 capful per litre, unless it's a difficult job, and then use anything up to neat. So now I remember doing the lathe, I got through a whole load of this stuff. So we'll give this a go. I mean, it would be great to have a parts cleaner, but I haven't got one, so this is the nearest I've got. And what I'll probably do with parts like this, I'll probably put them in the sandblaster, because they're not sort of precision parts. But this, for example, has got a bronze bush in it, and I wouldn't want to put that in the sandblaster really. There's a seal there, I have to decide whether to change it or not. Just an oil seal. Doesn't cost very much, £2 or £3, so I might do that. Yeah, I can feel the grease coming off it now, and it still feels nice and slippery. Yeah, so I think that's going to work quite well now. Yeah. I think that'll do for today. It's 5:10 and it's already getting gloomy, and then soon the clocks are going to change to make it lighter on the morning, and then we'll all be in gloom from about 4 o'clock. Great. Well, I hope you enjoyed that. Now, before we get on to the mystery machine, I just want to say thank you to a subscriber who sent me a soft copy of the manual. And although this is for the Mark 1, it's near enough the same to see that that tube I was talking about does indeed have the relief at the pulley end. So I was right. I don't know how long it had been on the wrong way around. But anyway, thank you, subscriber. I've forgotten your name just for a second, but I do appreciate that. It'll come in very useful. And also this pin here, I need to check this out, because I don't know if that pin extends into here on mine. I'll get that off because it may not be keyed. Anyway, that's a long story. I'm going to have to do the mystery machine on the PC. Sorry about that. I prefer not to. I like to put my face on the screen, but it's the only practical way to do it. I'm going to show you 4 pictures of the mystery machine. Now, this is owned by Stuart, who gave me the reamers. We think this machine came from Cookses in York, England, and Cookses was a very respected manufacturer of optical equipment. And Wikipedia tells me this started in York in 1837, and they were bought by Vickers in 1915. Now, Vickers was a very well-known heavy engineering and armaments manufacturer in the UK. They merged it with another company and it became Cook, Troughton and Sims, and then eventually it became known as Vickers Instruments, and it operated in York until quite late on. I'm going to say the 2000s. I don't really know, truthfully, but now the factory site has been knocked down completely. Anyway, we think this machine was used in the manufacture of optical instruments. So you can see that the machine has something like a lathe bed with V-ways on it. It has a tool post which is on a cross slide and then a top slide, and the top slide is operated by a pin with a lever, and as you pull the lever, the the top slide moves in and out towards the headstock. You can see that there are two headstocks, and the headstocks have got T-slots in them all the way around. So there's one on the machine now and there's one on the table in front. And I think there are two spindles available, one for each headstock. Now if you look at the headstock that's on the table, to the left of that there's a pulley with a spindle sticking upwards. So it looks like the spindle operates on a couple of cones. So it was never intended for high speed. If you look at the headstock that's on the machine, on the right hand end there's a big gear, and that gear is operated by a worm. Another gear at the front of the machine, because we're looking at the back of the machine now, and there was a handle over that side, so that made some kind of indexing mechanism as far as we can figure out. When we view the machine from the front, you can see there's a handle attached to that white block, and it seems pretty clear that as you turn that handle, that wheel, it will raise or lower the tool post. You can see that Stuart's also added on the tailstock there. So this doesn't have much distance between the headstock and the tailstock. In this final shot you can see that the handle that operates the top slide is fitted. So if we were to pull that handle towards us, it would move the top slide in towards the headstock. And then also, if you look at that gear, the large gear, on the left hand end of the headstock, that's driven by a worm, and that worm in turn is driven by a gear which you can see end on. And that's at the top of a slot. If you look down that slot, you can see a handle and another gear there. Now I guess you could put on different size gears, I don't know, but if it was engaged and you turned that handle, it would rotate the headstock. So it doesn't look like a super accurate machine. We think maybe it could have been used for slotting or making a spline or something like that. Hard one to guess, this one, but if you know, let us know. Thanks for watching.